This is a recording for Edexcel Further Pure 1. Vectors section 1.3, Finding the angle between vectors. Well, in previous videos we've seen both the definition of A cross B as mod A mod B sine theta, and then the n hat is in the direction of the vector, which remember is perpendicular to both A and B. So if A and B in one plane, then n hat is perpendicular to both of these. And we've also seen that we can calculate the components of A cross B using the formula which are given in your formula sheet, either in this form here as in its components form, or as a matrix and determinant of the matrix as here. Both of these are given. Now we can combine these two and therefore calculate an expression for sine theta, and sine theta will be just the size of the cross product A cross B, so mod A cross B divided by mod A mod B, very similar to the dot product formula which gives us cosine of theta. And indeed there's a difference, because sine theta is both positive for acute and obtuse angles. So we can't tell whether a particular angle is acute or obtuse by using the cross product. If we need to know that whether the angle is obtuse or acute, it's far better to use the dot product and get the cosine, which of course is positive for acute angles and negative for obtuse. However, in many questions what we're asked to do is to find the sine of the angle rather than the actual value of the angle itself. So what we need to do here in this expression is to work out, first of all, A cross B. We can do that using either the determinant method or the component method, and then to calculate the size of that cross product, and then the modulus of A and modulus of B. So let's do that. Well, A cross B, in this particular case, will be given by the cross product of A, which has components 1, -1 and 3, crossed with B, which is 2, -1, 2. And you can look up the formula, but remember that it will be A2, B3, so it's these two here, and then minus A3 and B2, so it gives us -2 minus -3, which of course is equal to 1. And then do check out that the other components are 4 and 1. So A cross B becomes 1, 4, 1. Therefore, the modulus of A cross B will be equal to, using Pythagoras' theorem, the square root of 1 squared plus 4 squared plus 1 squared. So that gives us square root of 18, which is equal to 3 root 2. Similarly, we can see that mod A is equal to root 11, so that's 1 squared plus 1 squared plus 3 squared is the square root of 11. And the modulus of B, so it should be an underlining under the A there, modulus of B will be equal to the square root of 2 squared plus 1 squared and 2 squared, which is square root of 9, which is equal to 3. And therefore, the sine of the angle theta, remember, is mod of the cross product A cross B divided by mod A multiplied by mod B. So that's going to be equal to 3 root 2 divided by the 3 and root 11. So we get root 2 over root 11, or the square root of 2 over 11. Let's just see that written out again. So remember this formula here, you're given in your formula sheet. We could equally well have done it using the determinant method, whichever you prefer, and both of them give you the cross product as being equal to 1, 4, 1, and therefore we can calculate the modulus of A cross B and the individual moduli of A and B, giving us the sine of theta. Remember though, we can't tell from that whether theta is acute or obtuse, and if you need to do that, then the dot product is much easier to do. Okay, well, that's the end of this video. In the next one, we'll be looking at how we can use cross product to find a unit vector perpendicular to two given vectors.